Hi, everybody. My name is Felicia O'Garrell, and today I'll be speaking to you on the image to text to image architecture. The image to text to image architecture is a powerful paradigm for manipulating and generating visual content based on textual descriptions. It creates a cyclical relationship, first analyzing an input image to generate a textual description, then allowing this text to be modified, and finally using the modified text to generate a new image. The project involves setting up an environment with key Python libraries like OCR, PyTorch, transformers, and diffusers, requiring sufficient disk space and preferably a GPU. A crucial step was extracting text from images using EasyOCR's optical character recognition capabilities. To generate textual descriptions from images, I implemented three pre-trained image captioning models: Salesforce's BLIP, the VGPT2 model, and Microsoft GIT model, trained on the COCO dataset. Each model offers different strengths in generating natural language descriptions. The project also includes a visual question answering component using the BLIP VQA model for interactive image analysis through natural language queries. To handle large-scale data, I integrated the COCO dataset with a custom dataset class and data loader for efficient processing. Completing the cycle, I explored two text-to-image generation approaches: Google's ImageGen and Stability AI's Stable Diffusion model, both allowing for new image generation from textual input. The project culminates in end-to-end pipeline, chaining these components from initial image text extraction and captioning to generating new images based on modified text. The modular design allows for model experimentation, and I've included examples demonstrating the pipeline's effectiveness on various images. My work on this project has reinforced my understanding that these AI tools augment creators with new capabilities, expanding the horizons of visual content generation. Understanding the underlying technology and practical building steps was key to successfully undertaking this project and harnessing its full potential. Now, starting off, I created a notebook, and for this notebook, I installed a number of different packages, some of which you can install. You can install in Colab or in Colab or in your Jupyter notebook, or actually in Anaconda if you're using Anaconda as well. From there, I made sure that I had sufficient disk space. So I did use a GPU because I do have some deep learning models, a lot that need to actually load. And then afterwards, I imported the different libraries that I use for this project. You can import as you move along. I just moved all the imports to the top of the project. Now, the first idea that I explored was text recognition and extraction, which is basically if you're given an image, it could be an image such as an image with a quote on it, or it could be an image, maybe you're at a ball game and there's different banners around the stadium and you want to capture that image and extract it. You can use Easy OCR for that. What it does is it recognizes and then it extracts the text. And for this section, I actually created two different functions, one to extract the text from the image using the library, and the other one to actually display the image. And this was my actual result. As you can see, the image, it highlights exactly what was detected in the photo. And then from there, I combine that text to create a caption. And here is the combined text for the caption that I'll actually pass into my text to image generation. So next was my text to image generation. So I used two distinct methods. One utilizes Google's image gen model via their API, while the other one uses Stable Diffusion. So as far as these two models, what I did was create functions for them, and the functions do require that you have an API key. So for ImageGen and also Stability AI, I needed to actually go and get API keys, which I actually did for both. And then from there, I define the functions. And then from here, I'm just generating the images based off of the text that was extracted using EasyOCR. So you can see me invoking this function, generate and display images. You need to pass in your Google Image Gen API key. Then from there, you can pass in the combined text. And this is the actual result that I got. And that's the result actually from ImageGen. The result from Stable Diffusion was this image. So you can see that the results are fairly different based off of the text that's given, but it is the same text, but these are the results that I got for the two. Moving along, I thought, hey, if we can extract text from images, I'm pretty sure there are models that are smart enough to help us identify what's actually on an image. And there are, and that technique is actually called image captioning, which I explored several different models for image captioning. As I mentioned earlier, I explored three different models. The first one that I explored was BLIP, and from here, I'm just defining the model. I have a function that's created, and all I need to do is pass in either the image URL or the path for this to run this model. As you can see, I have an image from Splash that I'm using. It's basically an image of, this one is an image of a brick wall that says, I make something special. And as you can see, after generating the model and running the model, the generated description says a brick wall with a sign that says, I make something special. And then from here, what I'm going to do is what I did was use my text to image. So I went back to the ImageGen API, and then I went back to the Stable Diffusion API. And this is what I generated with those captions. A brick wall with, I make something, I think, special. And then for Stable Diffusion, I make special. But pretty close to getting exactly what we needed. The next model I explored was the VIT GPT-2 model. And what I did was I created the model. Everything is included in the function. And that's my image to text. And then from there, I went back to I'm running the model based off of the image that I have. And the caption that it's generating is a cat laying on top of a couch next to another couch. So I went and I actually used my text to image, and I have Google's image gen. This was the image that was generated. And then for Stable Diffusion, this was the image that was generated. And that's pretty much a cat laying next to another cat on a couch. The next pre-trained model I used was a very large scale one. It's by Microsoft, and that's the Get Large Coco, large COCO model. And then from there, I created a function for this model. And the same thing for the function, all I need to do is actually pass in the image path. So I have my image, and I'm generating a caption. As far as my image, it says two cats sleeping on a couch to a remote control. So from there, I go back and I perform my text to image using Google's image gen. And we have two cats. And hey, we had three cats and there's a remote control. So maybe they didn't pick up that there were actually three cats in this image because one is actually hiding, but um, it did pick up the remote. As far as the Stable Diffusion API, gave me, looks like it could possibly be two cats and two remote controls. So the next section that I covered was visual question answering. And with the visual question answering, what you can do based off of the image that's loaded, you can ask questions. So I have an image, and the image has a woman. She has on a pink jacket and she's with her doll. So the question that I proposed was, what color is the woman's jacket? To see what answer I would get. So if we look, we can see that the question was, what color is the woman's jacket? And the answer that was provided is the woman's jacket is pink. And you can continue that cycle if you want to go on and just ask the model questions about the image. That can be something ongoing. It's like you're actually interacting with you're actually interacting with the model. And I thought that was actually pretty cool to share. Now, lastly, I wanted to try and make sure that everything that I was working on would be able to hold up to a large data set. So I used the COCO data set. I integrated that with two of the pre-trained models that I was actually working with. So I created a special data set and data loader for that. And then from there, I'm loading my captioning model, which is the VGPT2. And then from there, I'm actually loading a stable diffusion model, which I'm actually using for my text to image. And then I process the image. So process image to image, that's when everything comes together. That's when the image to to text to image all comes together. And then I'm ending my pipeline by displaying the different images. So for the first image, there's two men in the picture. They look like they're walking on the street. The generated caption was two men standing next to each other on a dirt road. And then the generated image was actually of a man standing on a dirt road. So that wasn't as accurate, but I've had a lot of images where I've had a lot of different scenarios where it's very, very accurate. Next, I actually have an original image, and then it's a man holding a tennis racket on a tennis court. And as we can see, we have the two men, one for the original image and then one for the generated image. Next, I have a bus is parked at a bus stop. So in the dark, that does look like a bus at a bus stop, but the generated caption, a bus parked at a bus stop, and then I have the generated image, a bus at a bus stop. The next image, people on the beach. This looks fairly accurate. A wooden bench sitting in the middle. The original image is pretty dark, but I feel like the models are pretty good at picking up exactly what's there. And lastly, a woman walking down the street in front of a store. So we have the original image and then the generated image. And that was pretty much it. I learned a lot throughout this process. So if anybody has any questions, feel free to reach out to me. But thank you so much for your time.